So to simplify this, the first thing we try to do is factor. So let's see if there's any common factors between the two terms that we have here. So 3x minus x squared, you can remove an x, it's true. You could take out an x, and you'd have 3 minus x. And I'm going to take a negative out of here as well. I'm going to take a negative out. I'll have 2x plus 1 here. Again, I'm just checking to see if there's any common factors between this and this. So plus, over here, I have 3 minus 2x. So that doesn't match up with anything. But now we have a quadratic. So it's possible that this quadratic has a factor in it, right? It has two factors, and one of the factors has something in common over here. But if you look at it very quickly, to factor it, you have to find two numbers that multiply to be 3, but add to be negative 1. So that's not forthcoming. So therefore, you're not going to be able to find any integers that will help this factor. So we'll just rewrite it as it stands. Okay. Either this quadratic has irrational roots or complex roots, and that's not really any concern for us when we're trying to factor. We would just check very quickly to see if we could factor this down into usual factors involving integers. Since we cannot, we just leave it as it stands. Okay, so now we have this expression, and we see there's nothing in common between the two. We did our best, but there's no factorization, which would be a simplification. There's no factorization possible. So now we will go ahead and just plug in the number 1, since this thing resisted any type of factoring. All right, so plugging in 1, we now have f prime, which is this expression right here, right? There's our f prime. F prime at 1, to find the slope of the tangent line, will be negative 1 plugged in, 3 minus 1 plugged in, 2 times 1 plus 1, 3 minus 2 times 1, and finally 3 minus 1 minus 1 squared. All right. So let's see. 3 minus 1 is 2. This is 3, so this is negative 6. 6. And what do we have over here? Yeah, 3 minus 2 is 1. 3 minus 1 is 1. So 1 times 1 is 1. So we have negative 6 plus 1 equals negative 5, I guess. Okay. All right. So let's just rewrite that very quickly. We know f prime at 1 is negative 5. All right. So therefore, the tangent line itself is y equals negative 5x plus unknown y-intercept. So what point does the tangent line have on it that we know for sure? Well, it shares the point of intersection with the curve at 1. So it's 1 comma whatever the curve value is, whatever the function value is, right? At x equals 1. That's the point on the tangent. Okay? So we look back at the original function. Right, there it is, 3x minus x squared times 3 minus x squared. We need to find f of 1 to get the corresponding y value for x. And that point is the one shared with the tangent line. So down here, we need also f of 1, not just f prime. So that equals 3 minus 1 squared times, 3 times 1, erase that, 3 times 1 minus 1 squared times 3 minus 1 minus 1 squared. All right, so 3 minus 1 is 2, and 3 minus 1 minus 1 which had a second ago, we had both these a second ago, really, is 1. 1 second, I feel like I made a mistake. No, that's fine. All right, so we get 2, and if f of 1 is 2, we now fill in x being 1, y being 2, and so we get 2 equals negative 5 times 1 plus b, subtracting 5, right? On this side, it's the same as adding 5 on the other side, so we'll get 7 equals b, and now we have our tangent line in full, just filling in the value of b. We have y equals negative 5x plus 7, and the problem is over.